So the diameter of this being 10 mm of the helical bar. Now, if we first calculate the area of cross section of this bar, that would be anywhere. If I cut a section of this bar, for example, I'm cutting the section of this bar here, what would be the area of cross section of this bar? That would be 5/4 d square. Now d is 10 square, so it's around 78.5 mm square. It's the area of cross section of this bar. Now next you need to know the length of this. लेकिन ये length कैसे है? If I show you a clearer picture, let me show you. If I can make it here. Not waste time like this. I will. So this is helical reinforcement.
Take into consideration too.
So you can see in this picture the winding going like this. If you check, there is, it's, for example, it starts from here and it's ending here. Now this is one pitch length. One pitch length is when it starts from here and it's ending here. Then you have another pitch length starting from here and ending here. Now, what is the length of this winding bar? How do you calculate that? How would you know? अगर ये सीधे ऐसे होता है as a circle, you would call it, it's 2 pi r. But this is not a straight circle. ये extend हो रहा है within the circle. The length of the ring is extending. You need to know the length of the ring to calculate the volume of the ring or of the bar. So how would you do that? That would be equal to the length of the helix. We call it as a helix is 2 pi r. R is the, or you can say pi d, 3.14 into d. D is the diameter of what? The circle in which it's enclosed. Which circle? This one. This is the core. Right from here up till here, you have the core of the. This is the core. This all is core here. even this portion. Included is the core, and all this portion. The core is within the red line, within the ring. Now your helix, this red one, the helical reinforcement, what is what would be the circumference at this location? That would be pi into d. D would now be 600 minus 40 minus 40. That would be 520.
500 minus.
G? Yes, 50 minus 50, right, at the center of this. Not, no, no, you have to calculate at the center of this. That would be 45 minus 45 and 45 here. That's 90. That's 510. 500
Sir,
minus.
it's 410. It is 500 totally, no?
Yeah, 500 minus 90. So ये होता अगर ये कंप्लीट एक सर्कल है, but it's not a circle, it's a helix. Now that would be multiplied by, you would have to multiply that, or by something else which would give you the length over the whole helix. What is that? There would be a certain factor by which you could multiply it. Which factor? Now देखो, तो अगर ये एक simple, it would have started from here and ended here. This is the break point here. Then this would be around 2 pi r. But now you are stretching this. आप इसको खींच रहे हो. जब आप इसको खींचोगे, अगर आप इसको नीचे खींचोगे ऐसे, the two ends will not meet then. So you require more length. So you almost require, now you cannot calculate that here, you require around 5% more. It's not given in the codes. You require a 5% more helix length to determine the length of the helix. Otherwise, you could just assume that it's equal to the circumference of the of this, which is not actually true. It's actually 5% around more than the length of actual length of the helix. So if you assume it's 5% more, then the actual length would be, there is one more way of doing this. You have to uh, calculate the length of the spleen. This is a spline length, which you have to calculate, and that's a cumbersome process to do. So we'll just assume it's something like this. It's 1351.77 mm. This is the length of the helix. Now, for one pitch length, this is for one pitch length. This is a one pitch length. What is pitch? Pitch is just simply this. Here, from here, this is ST. We designate it by ST from here up till this point. This is the pitch length. For that would be, this would be then equal to, for one pitch length, or you can say st. Now your volume of the helix or helical reinforcement is, for one pitch length per st, is how much area of cross section, that is 78.5 into 1351.77, both are in mm, so this comes out to be 106,113.945 mm cube. Next, you need to calculate the volume of the core of the column. Volume of core of column. Now, this is also per pitch length, you will be calculating this. Volume of core of column here would mean, now everything within the this helix, the rest of the portion within the helix, this portion you have to calculate, and because this is winding around, so this portion is also included in the volume of the core. Now, core is everything within this red except these longitudinal bars, that we can exclude, but for simplicity's sake we can take that also into account and say that the volume of the core is everything within. So because that is a small amount as compared to, so now that would be, the volume would now be this area within this red into the length, that is st, into the length, which is the st. So this would be 3.14 into, now how much is d here within this 50 and 50 card case mein, you have 100, that's 400 divided by 4, this whole divided by 4, 3.14 into this, so this is 125600 mm square. Yes, you have to now multiply it by st, the length. This is multiplied by st, which is the length or the pitch. So this would be mm cube. Now the volumetric ratio is this: the ratio of the volume of the helical reinforcement to the volume shall not be less than, so it should be always greater than this value, 0.36 into ag by ac minus 1. Now this ratio has to be greater than this value. So your ratio of volume of the helix or the helical reinforcement, which is 1 0 6113.945 divided by 125600 cross ST. This has to be equal to, at least equal to, first of all, because when you say greater than, shall not be less than, so it has to be at least equal to this ratio, which is 0.36 into AG. Now your, what is AG? AG is the cross section of, let me write it as AG first, divided by AC minus 1. There is a divide here by AC. This is AC into FCK by FY. Into FCK by FY. Now, how much is AG? That's 3.14 divided by 4 into 500 cross 500. We have already calculated this. It was 196250 mm square. Then what is AC? It's the area of the core of the helically reinforced column measured to the outside diameter of the helix. Now here in this case, he is saying that area of core is measured to the outside diameter of the helix. So you just have to subtract here when you are calculating for this AC. Don't confuse, here you just have to subtract 40 minus 40. So it's the diameter of the core. Actual diameter of the core is within the helix, but here it's saying that you have to measure it to the outside diameter of the helix. So this comes out to be 420 mm. Area of core or AC, AC जो ऊपर दिया हुआ है. So now you know FCK is 30, FY is 500. So you will get ST, the value of ST from here. So let's calculate the value of ST from here. That would be now AG by AC would be 196250 divided by 420. That's 467. 1. That's 0.36 into 30. 500. This is coming out to be 10. 10.07. 07. Any one of you?
सर सर इसमें हमने निकाला ना ये वॉल्यूम ऑफ कोर एंड वॉल्यूम ऑफ हेलिक्स, हमने दोनों में पर यूनिट पिच लेंथ के लिए निकाला, तो दोनों में कैंसिल हो जाएगा ना, वहाँ पे हमें लेंथ की जरूरत भी नहीं है ना सर।
आपने वॉल्यूम कहाँ निकाला वहां पर? वो तो ऐसे होगा ना, दिस इज कहाँ पर वॉल्यूम की जरूरत है ऐसे, दिस इज पर यूनिट, दिस इज पर, ये जो ऊपर है पर एस टी, दिस वुड बी 125600 into st per st, isn't it? आप जब वॉल्यूम इसका निकालोगे तो इट वुड बी एरिया क्रॉस सेक्शन इनटू द लेंथ फर्स्ट, वहां पर तो आपने निकाला ना उसकी लेंथ पर एस टी।
सर STR है 93.745 745
right, this is right. So you are getting the pitch 93.745. now that has to be greater than 75, which is the minimum that you provide, and the maximum that you provide is 300. It has to be less than 300. 300 is maximum pitch, both in rectangular and circular columns, and minimum is 375, both in rectangular and circular columns. So this is okay. Now you will not provide 93.745 in the field. What you will do, you will provide 90 mm pitch, lesser value than what is required. Why? Because decreasing the pitch means decreasing the spacing, means you are increasing the confinement. You cannot do the reverse here. You cannot increase here. You will say that I'll provide 95 mm. No, you cannot provide 95 mm because the max pitch required to you is 93.745. That's the spacing. So further you decrease it, more is the confinement. As soon as you increase it, you are decreasing the confinement. So you have to provide less than that value. So round it off to 90. So in the field, because it's difficult to provide 93.745, so we provide something like this. So we are providing the 10 mm dia bars at the rate of 90 mm center to center pitch length. This is a helical bar. Provide the 10 mm. You can mention here helix bar at 90 mm. So that this red one is what you have now provided. You can mark these things here. This is 10 mm at the rate of 90 mm center to center. You can say it's helix, 10 mm helix. Similarly, you can mark all these here in this diagram. This it's 6 number 20 mm bars longitudinal, or you can say longitudinal. So what else do you require to provide in a circular column? Now, apart from all these, do you require anything else? Yes. How do you end the helix here, which when I was mentioning, I was showing you the figure if it is there. Yes. You cannot tie the helix at the end. What you do, जैसे आप हुक बनाते हो in case of rings, you cannot do that. जितनी आपको required है helix to the end पे आप 1.5 turn एक और देते हो इसको. So you do something like this if it's somewhere here, because it's difficult to show otherwise. Now this column is ending here. The helix is going like this, like this. Now यहाँ पर तक तो आपका ठीक था. Now the column is ending. Then what do? आप एक और टर्न यहीं पर इसमें देते हो और फिर आधा टर्न और देते हो. So by that fashion you provide the anchorage at the end. So, जिसको हम गांठ बांधना कहते हैं. तो आप इसको एंड पे बांध रहे हो. So this was about the circular columns.